So let us start with the chapter correlation. Write down the definition first of all. Correlation is defined as joint variation between two variables such as change in one variable results in a corresponding change in another variable. For example, number one, price and demand of a commodity. Suppose if I consider that price is variable x and demand is variable y, then in that case, if the price of a certain commodity increases, then definitely the demand is going to decrease, because price and demand, they both are inversely related, that you have studied in your economics. Whereas if the price of the commodity decreases, automatically the demand will increase. So as there is a change in one variable, there is a change in another variable. So I can say that the price and demand of a variable are correlated with each other. One more example. Number of advertisements and volume of sales of a product. Now when we talk about number of advertisements, let us consider this is X, and volume of sales, let me consider this is Y. If there is any company which is producing some items, definitely it has to do the advertisement for that particular new product or the new item. Because if the public doesn't know about that particular new product, definitely nobody is going to purchase that product. So if the company does a lot of advertisements, that is a huge number of advertisements is done for that product, automatically the sales of the product will increase. Whereas if the company doesn't do any advertisement, it just stays like that only, just doesn't do any kind of advertising or anything, then definitely the sales of that product will be very less, or probably there will be no sales of that product. So I can understand that the number of advertisements and the volume of the sales, they both increase or they both decrease at the same time. Looking at the above two examples, we can see over here that there are two types of correlation. One is positive correlation and the other has to be obviously the negative correlation. Now when I talk about the positive correlation, I understand from here that both variables tend to move in same direction. That is, for the two variables x and y, they both will either increase or they both will either decrease. Like we saw in example number 2 above, related to number of advertisements and the volume of sales. Whereas if you talk about the second case, negative correlation, so in this case both variables tend to move in opposite directions. So when you talk about tend to move in opposite directions, so if I have the variables x and y again, if x increases then y can decrease, or if x decreases then y can increase, like we saw in the above example of price and demand of a product. The next part is the methods of studying correlation. There are only two different methods. One is graphical method and the second is algebraic method. But the thing is, under graphical method we have one type called as scatter diagram, whereas in case of algebraic method we have first method given by Karl Pearson called as Karl Pearson's correlation coefficient. The second is Spearman's rank correlation coefficient, and the third one that you have is coefficient of concurrent deviations. So let us start with the first method first, which is based on the scatter diagram. So let us start with the points related to the scatter diagram. The first point is that it is a graphical method to study correlation. So point number 2, it gives only approximate idea about type of the correlation between the variables under study. It does not give exact value of correlation between the variables. Point number 3, it does not give degree of correlation. When we talk about degree of correlation, so it means that the value of the correlation, numerical value, we don't get from scatter diagram, we don't get from the diagrammatic method of calculating or finding the correlation. We just get the idea about the type of correlation. Now when I talk about the type of correlation, it means that only it helps us to understand whether the correlation is positive or negative. There is one very important point that we need to write over here, point number 4. It is suitable for studying both linear and curvilinear correlation. So when we talk about linear correlation, it means that the points, the data that lies on the near about a straight line. Whereas when we talk about a curvilinear correlation, it may happen that all the points are not in a straight line, but the points are having a curved kind of a formation. Like see, it is like this. Suppose if you have x and y axis, so the points can be having this kind of a formation. So from here I can understand that approximately there is a rising tendency like this. Then this kind of a formation is called as a linear correlation. Whereas suppose if you are having something like this, then it is approximately this kind of a formation, which is called as a curvilinear correlation. Curvilinear it is called because it has a curved kind of a formation. Okay. So after this, the next point that we have, there are some different points under this. So write down point number 1. Perfect positive correlation. Let us draw a rough diagram like this. If the plotted points lie on a straight line, this is our x-axis and y-axis. If the plotted points lie on a straight line which has a rising tendency from lower left to upper right. Then it gives perfect positive correlation Point number 2, strong positive or high positive correlation. Again, let us draw a rough diagram for this. In this case, you will observe that the points are again having a rising tendency. But the points are not on a straight line, they are very closely clustered with each other. So here we say that if plotted points lie closely clustered with each other, and have a rising tendency from lower left to upper right, then it gives strong positive, or as you can say high positive correlation. Point number 3, weak positive or low positive correlation. Again a rough diagram for that. That's your x-axis and the y-axis. In this case, the points do show a rising tendency, but you can observe over here that they are not very close to each other like we had in the above case. The points are slightly away from each other. So I can say over here that if plotted points lie in a wide band which have rising tendency from lower left to upper right, then it gives weak positive or low positive correlation. Point number 4, it is now similar to the above 3 that we have just now written: strong negative, high perfect negative, strong negative, and the weak negative. So let us write down point number 4. Perfect. Okay. Again, let us draw a rough diagram for this. Now see, in the above case, we had told that there is a rising tendency of the points in case of a positive correlation. Whereas in case of a negative correlation, they will have a falling tendency. Now because it is a perfect negative, so the points are lying in a very straight line. So we say that over here, if all the plotted points lie in a straight line and have a falling tendency from upper left to the lower right, then it denotes, or you can say shows, perfect negative correlation. Point number 5. Strong negative or high negative correlation over here. The points are again clustered along with each other and they are showing a falling tendency. So I can say if plotted points are closely clustered with each other and have a falling tendency from upper left to lower right, then it gives strong negative or high negative correlation. And point number 6, weak negative or low negative correlation. Just similar to the previous case, the points will still have a falling tendency, but they are slightly far away from each other compared to the above case. So we will write over here if plotted points lie in a wider band that has a falling tendency from upper left to lower right, then it gives weak negative or low negative correlation.